This is the video solution to practice problem A that accompanies sample exercise 4.14 in your textbook. This is a problem-solving video on titrations. This particular problem asks us to calculate how many milliliters of 1.42 molar sulfuric acid solution are needed to neutralize 95.5 milliliters of 0.336 molar potassium hydroxide solution. The word neutralize in this problem means to completely react. So we will need to determine how sulfuric acid and potassium hydroxide react with one another. This will be done using a balanced equation. We can recognize that H2SO4 is an acid and KOH is a base. When these compounds react, we think about a double replacement reaction occurring where cations and anions switch partners. The result of the replacement reaction leads us to identify water coming from a hydrogen cation and a hydroxide anion as one product, and then potassium sulfate coming from the potassium ion with its charge of +1 and the sulfate ion with its charge of -2 as the other product. Now this chemical equation is not balanced, but balancing it is relatively easy. We'll need to show 2 units of potassium hydroxide and 2 units of water in the products. And now we have a balanced equation that we can use to solve our mole problems. The solution to this problem needs to be milliliters of sulfuric acid. We know that it takes 95.5 milliliters of 0.336 molar potassium hydroxide solution. So I'm going to write each of these values under the respective compound in the balanced equation, just so that I can keep track of which numbers go with which compound. It'll help me solve the problem. Here it is. Here's the balanced equation again. And I'm going to ask you to think about one of the images that appears in your textbook. That image can be fairly complex, but it has us think about moles of one compound, we'll just call it A, and moles of another compound. In this problem, we need to find out something about the sulfuric acid when we know a lot of information about the potassium hydroxide. So A in this particular reaction, in this particular problem, will be potassium hydroxide. B will be the sulfuric acid. And we already know that we can get into and out of moles of any compound or element using either mass or using molecules or atoms. And now, after we have been through a little bit of chapter 4, we also know that molarity can also be a link to the number of moles of anything involved in a balanced equation. And here in particular, we're going to think about the sulfuric acid again as our final calculation. We know that we're going to start with the potassium hydroxide, and we'll fill in those values or those compounds and know that basically we're going to start here with the molarity and volume of potassium hydroxide. We'll want to calculate moles of potassium hydroxide, convert that into moles of sulfuric acid, and then eventually find the volume of sulfuric acid. Alright, so if we go back to the data that we were given, we know the most information about that potassium hydroxide solution. And as a first step, we'll need to take the volume of potassium hydroxide in milliliters and convert it into liters. And the reason we have to do that is that our molarity is always known in moles per liter. So in order to calculate the number of moles of KOH, I have to know the volume of the KOH in liters. That's a fairly straightforward metric conversion. And I could say then that I have 0.0955 liters of potassium hydroxide. I could stop there, or I could simply take my units that I have at this point, which are already in liters, and say that my molarity actually means for every 1 liter of potassium hydroxide solution, I'll have 0.336 moles of KOH. And at this point then I could solve for the number of moles of KOH and have a value. Once I know the number of moles of KOH, then using a mole ratio, I can figure out the number of moles of sulfuric acid, and that's a mole ratio just like the mole ratios that we talked about in chapter 3. We need to have moles of potassium hydroxide in the denominator. We see from our balanced equation that we need a ratio of 2 moles of potassium hydroxide to react with every 1 mole of sulfuric acid, and as a result then we'll get 0.0161 moles of sulfuric acid that had to come along with our initial solution during the course of the reaction. One more step will allow us to figure out the volume in milliliters of sulfuric acid. We knew that the sulfuric acid solution was 1.42 moles per liter. We have already determined that the number of moles of sulfuric acid divided by the number of liters is equivalent to molarity. So here's our molarity, and we will find the number of liters. We can do that through division if we need to. But we knew from our previous calculation that we had 0.0161 moles of sulfuric acid based on how much potassium hydroxide was involved in the reaction. Here's our moles divided by our molarity that was given to us, and dividing these two values out will give us a value of 0.0113 liters. In one more metric conversion, we could solve for the number of milliliters of sulfuric acid that are needed, and I'm not going to show the work for that because I know you can all carry out that metric conversion. The final answer to this problem would be 11.3 milliliters of H2SO4. This video showed how to solve this problem in a series of sequential steps, and please know that each of these steps could have actually been strung together in a dimensional analysis problem. So either approach is completely mathematically correct, but in any case you will always need to have a balanced chemical equation and some way of linking moles of one thing to moles of another, as long as those two entities appear in the balanced equation. I'm going to ask you to think about practice problem B of this same sample problem. That practice problem forms the basis of your video quiz. So once you have taken a look at practice problem B, then go ahead and take the video quiz and carry on with your titration problems.